section, we will talk about priority-based eviction, cost-based eviction, and size-based eviction because they share the same idea, so we will cover them in a single video as a single unit. In this eviction policy, we assign a priority to each cached entry. How we calculate the priority is an implementation detail. As an example, a viral video or tweet would have a higher priority than a simple video or tweet. So in this policy, each item has a priority associated with it. And when we have to evict an item, we always choose the item with the lowest priority. Suppose we are building a cache for a task scheduler. So the tasks with lower priority would always represent less critical tasks. And when the cache is full and a new task needs to be cached, in the priority-based eviction, we can always evict the task with the lowest priority. The priority-based eviction is suitable for scenarios where the items have different levels of importance and the cache needs to be optimized based on these priorities. Similarly, in cost-based eviction policy, we associate a cost with each cached item. There could be different ways to calculate the cost of an item. It could be usage based or resource consumption based. That means how costly it is to create a new instance of that item. Suppose if an item is actually very costly, in that case, we would want that item to be in cache for a very long period of time rather than instantiating the same object again and again because it's costly. So in this policy, entries have a cost associated with them. It could be a numerical value or any other value that represents the cost of an item. And when the cache is full and we have to evict the elements, we may decide to evict either the low cost values or the high cost values. It depends on the use case. Then we have size based eviction, which is pretty simple to understand because in this policy, we store the item, we store the cache entry, but we also store the information of its size. And when we have to evict the elements, we evict the elements based on their size. Suppose we are building a cache for images. Each image has a size, so we also have the information of their sizes. When the cache is full and we have to add a new image, in this policy, we can always remove the image which has the highest size to make room for the new images. The size-based eviction policy is very useful for scenarios where the size of the item is a critical factor and we are conscious about the size of cache. So to manage the overall size of the cache, we evict the items based on their sizes.